In this video, I want to discuss how to solve inequalities involving rational expressions. For example, suppose you wanted to solve this inequality. Okay? Now, you may recall that solving inequalities is a lot like solving equations. Where they differ is when you have to multiply or divide by a negative number. What if you multiply or divide by an expression involving variables? In that case, you want to make two columns, and in one column account for the possibility that the expression is positive. In the other column, account for the possibility that the expression is negative. Okay? And another thing to keep in mind when you have lots of rational expressions is if you multiply by the least common denominator, you get rid of all your fractions. Isn't that great? Get rid of all your rational expressions. All right? So let me do this. Let me solve this inequality to give you an idea what I'm talking about. So I'm going to multiply both sides by x so that all my rational expressions go away. All right? And so I don't know whether x is positive or negative, so I'm going to account for both possibilities. X is positive will be in this column, x negative will be in this column. So in the first one, let's go ahead now and distribute the x. 2x minus 3 is greater than 5. In the other column, 2x minus 3 is less than 5. All right, here we go. We're going to now simplify. I'll add 3 to both sides, so 2x is greater than 8. Divide both sides by 2. X is greater than 4. In the other side, I'll do similarly. 2x is less than 8. X is less than 4. All right. So now let's look at what we have. In the first column, we have several inequalities. They all have to be true of our answer. Now let me focus on the first and last one. The number has to be, or the number can be, greater than 0 and greater than 4. All right, can you see that both of those conditions is equivalent to simply demanding that x is greater than 4? In the second column, let me focus on the first and last inequality. The values can be less than 0 and less than 4. Can you see that both of those conditions are met when x, simply requiring that x is less than 0, when x is simply less than 0? Okay, so those are the two possibilities. Putting it all together, the answer is x is less than 0 or x is greater than 4. Okay, now it is an excellent idea to pick some values that satisfy your solution set, that are in your solution set, and see if indeed they satisfy the original inequality. All right, so for example, what's the number less than 0? How about minus 1? Let's plug in minus 1 into the original inequality and see if we have a true statement. And indeed we do. Okay? Let's see, x can also be bigger than 4. What about 10? So let's replace x with 10. So 2 minus 0.3, is that greater than 0.5? Is 1.7 bigger than 0.5? The answer is yes. So now we've increased our confidence that our answer is correct. All right. Would you please pause the video now and try to solve this inequality? 2 over x plus 3 over x is less than 10. Okay, I'll go ahead and solve it myself now. So I'll multiply both sides by x as before, and I'll account for the two possibilities, x being positive and x being negative, and let's see what happens. So if x was positive and I distribute the x on both sides, 2 plus 3 is less than 10x, 5 is less than 10x, divide both sides by 10, so x is greater than a half. On the right side, 2 plus 3 is greater than 10x, 5 is greater than 10x. Divide both sides by 10. X is less than 1/2 after you simplify. All right, now let's see if we can simplify things and polish our answer further. So on the right side, we have the requirement that x is greater than 0 and x and greater than 1/2. So that's the same as simply being greater than 1/2. On the right side, x has to be negative and less than 1/2. That's the same as simply being negative. So putting it all together, the solution set is x is less than 0 or x is greater than 1/2. Go ahead and plug in two numbers that satisfy pick two numbers that are in our solution set to confirm that they satisfy the original inequality. Okay, now one choice could be -1. So let me show you that -1 will indeed give us a true statement. So -5 is less than 10. Yes, that works. And for a number greater than 1/2, how about +1? So 5 is indeed less than 10. So that we've increased our confidence in our solution again. All right, let me close with one more example. Would you please solve this inequality? All right, so pause the video if you like and try to solve this one. Okay, I'll go ahead and solve it too. I'll multiply, again, both sides by the least common denominator and then account for the possibility that the expression I'm multiplying by is positive and negative. X plus 1 positive, in other words, x plus 1 is greater than 0, and x plus 1 is less than 0. Okay, so distributing the x plus 1 gives 2 times x plus 1 minus x is greater than 3 times x plus 1 minus 9. On the right side, we would have the same, except that the sign of the inequality is going to be reversed. Okay, all I did there was distribute the binomial x plus 1. All right, so continuing, 2x plus 2 minus x is less than 3x plus 3 minus 9. So simplifying, let's see, x plus 2 is greater than 3x minus 6. Subtracting x from both sides and adding 6 to both sides, I get 8 is greater than 2x. On the right side, we will do similarly. And you can probably guess what we're going to get. So we get 8x, or excuse me, 8 is less than 2x. Okay, divide everything by 2, so 4 is less than, or 4 is greater than x, and on the right side, dividing by 2, 4 is less than x. Okay, now let's analyze the inequalities. So the first one said that x plus, the one I just circled in purple, said x plus 1 is greater than 0. That's the same as saying that x is greater than minus 1. You can see that by dividing both sides by, or excuse me, subtracting 1 from both sides. All right, and then of course we have x is less than 4. Okay, on the right side, we have x plus 1 is less than 0. That's the same as x is less than minus 1. You can see that by subtracting 1 from both sides. And then we also have that x has to be greater than 4. Now, is it possible for a number to be less than 1 and greater than 4? No, it's not, is it? So we discard the right column. There's no values that satisfy the inequalities on that side. So I gave you this example to show you that sometimes you have to throw out certain columns. All right, so the only remaining solution is that x has to be greater than minus 1 and less than 4. So the nicest way to package all that is the following. All right, and there you have it.